All right, guys, for this DLD, we are going to go over your week 29 coordinate planes. We are going to go over each problem on the homework. I think coordinate planes should be enough of a review that we can just do this. So instead of taking notes this week, you could watch this video and take notes if you want, or if you want to watch this video and then go straight on and try out the homework and see how you do on your first attempt. That's okay too. And then during the week I can teach, but your DLD assignment is to at least attempt the homework one time all the way through after watching this video. Okay, so let's go through each type of problem. The first problem, give the location of Rome as an ordered pair, x, y. Okay, so we find Rome. Rome's right here. Now the way coordinate planes work, and we'll talk more about this later, but we have a number line here, the x-axis, and we have a vertical number line here, the y-axis. So the x always comes before the y. The way I like to think about it is there's a ladder, okay? And you start your ladder at the origin, 0, 0. Now, you can't climb a ladder first and then move it. It doesn't work out too good. You gotta move that ladder first to the left or right and then climb up or down, okay? So Rome's over here. So the first thing I need to do is move the ladder over this way until I'm on top of Rome, which is right here at positive 7. So the x is 7. And then I'm going down the ladder until I get to here, which is at negative 10. So I'm going 7 to the right and then down to negative 10. So those are the coordinates of Rome. Okay. X comes before y. Next, using the pencil, plot the point -4, -1. So again, I start at the origin, start in the middle, I go -4, and then I go -1. Plot the point. Okay, it's problem 2. Problem 3, now we're going to do it with fractions. Plot 3 3/4, 2.5. Okay, so I'm going to go over to 3. And then I can see it between 3 and 4, it's broken up into fourths. So I'm going to go over 3 out of 4. So I'm going here. And then I'm going up to 2.5. Here's 2, here's 3. It's broken up into fourths. So, I mean, it's obvious, but let's change it to fourths. 1/2 is the same as 2/4. So I need to go 2 and 2/4. So it's where these 2 points meet. Go up here, over here, that's where I put my point. It's a little bit difficult to do an Alex, but if you play around with it a little bit, you'll be able to tell you're halfway between the lines. You're more than halfway to 4. Now when we get negative numbers, that's where sometimes we get a little bit confused. Okay, so now we're going 3 1/4, -3 1/4, 2 3/4. This is a common mistake, watch me here. I'm going -3, and then I'm gonna go 1/4 more. I'm not going back this way towards 2. That would be 2 3/4. I wanna go -3 and then 1/4 more towards 4. So I'm going over here, not back towards my origin. And then up 2 3/4. So there's 1, there's 2, and 2 3/4 right there. So there's 2, 3, 4/4, 2 3/4. Okay, don't make that mistake of going back towards the origin. Name the quadrant or axis where each point lies. Okay, so talking about quadrants, this might be a new concept to you. It's a pretty easy concept. This is the quadrant we use the most with positives. So that's quadrant 1. We use Roman numerals for this. And then we go counterclockwise. So over here is quadrant 2. Because it's the one we use the next most often, because we're going on the x this way up, this way up. So this is quadrant 3, then this is quadrant 4. We have 4 different quadrants. All the points in this are going to be positive, positive. It's the one you're used to the most. Positive x, positive y. These are going to have a negative x and then a positive y, because you're going to go negative, positive. Over here we have negative and then a negative. So we have every point in this quadrant will be like that. Over here they're going to be positive and then negative. Okay. So that's just a brief run through of what your coordinates will be. Remember, when you're writing coordinates too, coordinates are always two numbers, coordinates, co means two, and you're gonna have a comma between them, and you're gonna put parentheses around them, always. That's proper notation for that. Okay, and then we also, obviously this is my y-axis. X is what we use the most. X is kind of the shorter, fatter one, where y is long, up and down, y. Okay, x-axis, y-axis. Okay, so point D is in quadrant 1, Z is in quadrant 2, K is on the y-axis, and Q is in quadrant 4. All right. Next problem, name the quadrant just by looking at this, okay? Like we just talked about, we're going positive and then negative. This one we're not going over anywhere, and then negative, okay? So I could draw this and I could just roughly eyeball it. Remember, 1, 2, 3, 4, this is my x, this is my y-axis. Okay, so 3, negative 4. I'm going this way, 3, down, negative 4, so that's quadrant 4. 0, negative 7. I'm going over 0, so I'm not moving anywhere. Then I'm going down, negative 7. So this is on my y-axis. Negative 7, 6. So I'm going negative 7, 6, quadrant 2. Negative 3, negative 1. Negative 3, negative 1, quadrant 3. I suspect the x and y-axis is what's going to mess most people up on that topic. So pay close attention to which line you should be on. Name the quadrant where the point lies. The x-coordinate is negative, y-coordinate is positive. So that's quadrant 2. The x-coordinate is positive and the y-coordinate is 0. Ooh, think about this one. X is positive and then it's 0, so it's right on the line, right on the x-axis. Question 8. Find the distance between C and D. So now we're going to change this up a little bit and find distance. Okay, so let's first find the coordinates. This is at negative 6 and then up 4. This is at negative 6 and then down negative 3. Okay, so we don't have to worry about the x at all. This doesn't matter to us. They're both the same. If they were different, then we'd get a lot more complex, but they're not. So now we just have to figure out, this is the same as if it would be on 4 on a number line, and this would be at negative 3 on a number line. We're finding the distance between 4 and negative 3. How far apart are those two? Well, we know from 4 to 0 is a total of 4, and we know from 0 to negative 3 is another 3. So total, 4 plus 3, they are 7 apart. Now we could just count 1, 2, 3, 4, 5, 6, 7 spots. Count the spaces, not the line. But you can also find distance to 0, distance to 0. This is the same as 4 minus negative 3. If we have two negatives, it's a positive. 4 plus 3, 7. Don't say they're 1 apart from each other. You can just look at that and see that that makes no sense. Okay, number 9. Okay, so now you don't have a graph. Find the distance between these points, negative 7, 6, negative 7, negative 4. So ignore the negative 7s, they're the same. So we're finding the distance between 6 and negative 4. Okay, so if here's ground level, and this is 6 feet above, and this one's 4 feet below, they're not too apart from each other. We have 6 here, and then we have 4 more here. So they're a total of 10 apart. 6 minus negative 4 is the same as 6 plus 4, which is 10. Okay. We could also think of this in terms of absolute value. Negative 4 minus 6, the absolute value of that is negative 10, which is 10 apart. All right, find the distance between 6 and -4, -3 and -4. Okay, so my y's are the same this time. It's my x's that are different. So if here's my coordinate plane, this is over here at +6, and this is this way at -3. Okay, so that's 6 away from 0 this way, and 3 away from 0 this way. So 6 minus -3 is 9. They're 9 apart from each other. All right, that's your homework this week. If it's helpful on 9 and 10 to make a drawing like this so you can see it, do that. So I do want you to attempt the homework right now. If you want to do it multiple times, that's fine, but I want you to at least make one attempt. Okay, good luck on this.